Hey guys, I hope your weekend's going well. As I was kind of thinking about your homework assignment that I had given you for this weekend, um, I started to think that we hadn't really gotten a lot of practice graphing some function rules in class. We did a little bit. We did a handful of them on Friday, but I wanted to make sure that nobody was really just completely lost with what they were supposed to do on the homework. So I decided to create a quick little video just so that you guys could, so we could go over a couple of those homework questions, and hopefully you could use the information that I provide in this video to answer the rest of them. So we're going to go over 2 of the homework questions really quickly, and then hopefully you can do the other 4 on your own. So our homework was about graphing functions, and let's go ahead and do that. So number 1 from the homework assignment gave us a function that said y equals 2x. And of course we're going to notice that they didn't exactly write this in function notation. They wrote it as y equals 2x, and we do recognize that y equals 2x means the exact same thing as f of x equals 2x. It's just written in a different form. Remember that variable y can be rewritten as the variable f of x. And what they've asked us to do here is they have asked us to graph this function on a very specific domain. They want us to graph it on the domain -2, 0, 2, and 4. If we recall from the last couple of weeks, the word domain means input. They are giving me input values. They are giving me numbers to plug in, and I am going to find out what comes out. So I'm going to make a little chart here, a little xy or a little x f of x chart, since we're talking about function notation. And I'm going to plug in each of my domains. I'm going to put all my inputs in the left-hand side of my chart. -2, 0, 2, and 4. And then I'm going to plug them into my function. I'm going to say, well, what happens when I take this -2 and plug it into my function rule? Well, that means that f of -2 is equal to 2 times -2, which is -4. So when I input -2, and I'm going to go to my graph over here and graph that, careful when you graph on here because notice that they're counting by 2's. So if I input -2, and I apologize for that because unfortunately my board is not quite calibrated, so it's a little bit tricky to figure out where I should be going. If I go to -2 on the input, then I'm going to go down to -4 on the output. And I'm going to create a point right there, -2, -4. And then I'm going to continue to do this process for each of my input values. When I input 0 into my function, I get 2 times 0, which is 0. That means that this passes right through input 0, output 0, which is the origin. And then I'm going to plug in 2, and I'm going to get 2 times 2, which is 4, which means when I input 2, I output 4. And finally, when I plug 4 in, I'm going to get 2 times 4, which is 8. When I input 4, I output 8. Okay? And then what kind of function is this? Think about that for a moment. What kind of function is this? Use all the words you can to describe this function. Right, so there's a couple of words we can use for this function, and the first is discrete. We are not going to connect all of these dots and make it look continuous because the domain is specifically asking about 4 points. So this is a discrete graph, and of course it forms a straight line, which makes it linear. So the 2 words you should have used to describe this were linear and discrete, and that's all that our graph is going to look like for this particular question. All right, let's move to another homework question real quick. I'm going to jump to number 5, because number 5 is slightly different. 1, 2, 3, and 4 on the homework were all the same. I was giving you specific input values, and I was asking you to find output values. But this question is just a little bit different because I'm not giving you input values here. I haven't given you domains to use. So I want you to graph this function for all of the domains. Well, that seems a little bit tricky, doesn't it? We don't want to try to plug in an infinite number of points here. So all we're going to do is we're going to pick some really easy numbers to deal with, and we're going to solve our equation for those numbers, and we're going to assume that it's going to follow some kind of pattern, and we'll create a continuous graph from that. So let me give you an example. Again, we'll make a little xy chart or an x f of x chart. Means the same thing. I'll go with xy since that's what they're actually using here. And I'm going to input some values. I'm going to input some domains. Well, what domain should I use? It doesn't matter, because what they're about to have us do is graph the entire function for all domains. So any numbers I plug in here will work. Therefore, it makes the most sense to plug in some really easy numbers that are close to 0. So I'm going to plug in some numbers like, let's go ahead and plug in -2, -1, 0, 1, and 2. I'm going to plug in those 5 numbers and see what happens to my function. Notice that I picked a couple of negatives and a couple of positives, just so that I can try to get a feel for what the entire function is doing. So let's go ahead and plug these inputs into our function. We've got -2 squared plus 5. Well, -2 squared, -2 times -2 is 4. But there's another negative hanging out in the front right there. And that's going to mean that I am going to get -4 plus 5, which is 1. When I input -2, I get out +1, something in that neighborhood right there. And then I'm going to do the same thing for -1. -1 squared plus 5. Well, -1 times -1 is 1. Times that little negative in front of it is -1 plus 5 is 4. So when I plug in a -1, I'm going to output 4, something around there. And then I'm going to put my 0 in, and I'm going to get -0 squared plus 5. Well, that's just going to give me 5. So I've got another point right around there. And then I've got my -1 squared plus 5. Again, 1 times 1 is 1. The negative in front is -1, and -1 plus 5 is +1. So I get a point right about there. Sorry, -1 plus 5 is 4. So when I plug in 1, I get out 4. And finally, when I do the same thing with 2, -2 squared plus 5, that's 2 times 2 is 4. The negative in the front is -4, and -4 plus 5 is +1. Input 2. Output +1. And we get something that is very symmetrical here. And because we're graphing for all domains, not just a particular set of domains, we want to make this look continuous. And in order to make this look continuous, and again, bear with me because my board's not quite calibrated correctly, there's going to be some curves in here, something like that. And it's going to go on and on towards infinity in both of those directions. We've talked about this shape in class. This shape is called a parabola. And what makes it a parabola, what makes it curve back down to where it started, is this x term. As soon as I see that squared, x to the 2nd power, I know that I'm going to be getting a shape that is a parabola. That's that U shape. So hopefully that helped you answer number 1 and number 5. And then I'd like you guys to go ahead and take a look at number 2 and 3 and 4 and 6 and see what you come up with. We will talk about it in class tomorrow. We're going to continue to graph functions in class until we get more comfortable with it. But hopefully this will get you started on the right path. I hope you guys have a good rest of your weekend, and I will see you guys on Tuesday.